Welcome to the Defense and Aerospace Report's monthly technology report sponsored by General Motors Defense. I'm your host, Vago Muradian, here in Concord, North Carolina, just outside Charlotte. Later in the program, what one small company with a good idea is learning as it tries to break into the defense business. Joining us now are Fred Maxik, a former NASA scientist who is the co-founder and chief technology officer of a small Florida company, Healthe. That early in the COVID pandemic developed the first ever human-safe ultraviolet system to disinfect folks as they pass through doorways and other areas. And Dr. Wes Naylor, a retired United States Navy captain, who's now the CEO of 50-Pound Brain Ventures. Fred, great to have you on the program. And Wes, welcome back. It's been too long.
Thanks, Vago.
Thank you.
Fred, let's start off with you, right? I mean, folks know about the disinfecting properties of ultraviolet radiation. Consumers have been able to buy units that will disinfect surfaces, whether sheets at hotels or toothbrushes and the like. But the big challenge has been figuring out, right, how do you disinfect people? Because fundamentally in this pandemic, we've found that there isn't enough hand gel and bleach to go around, and it's labor intensive. Whereas if you can get people actually moving and dealing with the aerosolized problem is the big thing. What's so special about what you guys do that nobody else in the world is doing?
So the major difference we have today is light, as we've used it in the form of UV, has always been 254 nanometers. That is standard UVC light that comes out of a mercury vapor tube. We've used it for decades in hospitals and restaurants and some of these wands you just pointed out. How effective they are is a mixed bag, and I think that's a separate conversation. What we have today is a new form of UV light. It's called Far-UVC, and this is 222 nanometers. 222 nanometers has some very, very unique properties. One is it's devastating to pathogens. It can destroy viruses, it can destroy bacteria by making them and rendering them inactive. The other property that's unique to it is it doesn't penetrate the human skin. It doesn't penetrate the human eye duct and the tear layer. It is basically been found to be a safe form of light by multiple independent university studies, independent peer-reviewed journals around the world now for this past decade. And what we have uniquely is we have product that contains this light source that we manufacture for uses across many areas within our environment.
And so where are you guys in the commercialization, right? Where are you in your development stage at this point? Any customers yet?
Yeah, many customers. We first of all, we were not new to this field because of COVID. We've been active in this field and developing product in this field for about 7 years now. I did some of my work with NASA 13 years ago on looking at how we utilize UV light to clean our environment. So this was not new to us. We've been in this space for a while, and we're in some of our products already on our third generation of products. So we have numerous commercial products out there. We've been out there for quite some time, and we have installations across the country.
Fred, how quickly does this work, right? Because I mean, one of the challenges with this kind of technology is, well, you got to keep the wand on it for an X period of time. How fast are we talking about?
So with something like the wand, and depending on the pathogen can be inactivated in as little as a third of a second. So we're dealing with very high fluence levels, not like the sort of consumer wands you see on the market today.
From a NASA perspective, you constantly have to disinfect people as well as make sure that you're not putting contaminants on spacecraft, right? I mean, it would suck to go all the way to Mars and then find out that, you've got contamination on it and you think, wow, we found life. It just turns out it's Bob's chicken sandwich. Wes, talk to us a little bit, right? It's not good enough to have a really good idea, right? Getting it into the military ecosystem is a challenge. You're a former aviator, but also an acquisition professional. You were working with Naval X team and others in the Navy and up at the Pentagon. Talk to us a little bit about the challenge of taking what is a really, really good idea, getting it through the valley of death and to the attention of folks in DoD, right? You may have a product that solves their problem. The system makes it a little bit hard to get that product in front of the customer.
Well, Vago, I think you're hitting exactly. Certainly, the acquisition leadership in DoD and the associated rapid acquisition organizations that have sprung up over the past 4 to 5 years, are open to working with non-traditional defense firms and non-traditional firms like Healthe to take what is cutting edge dual use technology and bring it into the military domain. Now, I first started working with Healthe when we were seeing problems with Navy ships having to pull into port. And the question was, how could we use technology to allow for continued operational effectiveness? And there were three things that obviously we had to attack. At first, when COVID was coming out, we thought the surface, it was all being spread on the surface. So we somehow had to be able to protect the surface vector. Secondly, we knew it was being spread through the air. At the beginning, we thought that was only about 30% of it. Now we know it's the vast majority. So how do we protect the air vector? And then third, you've got people and things coming on and off a ship. So they could potentially be bringing in. So how do you protect that vector? And what it comes down to, much like we learned about defending a structure after 9/11, there's not one silver bullet for this. It's a risk management equation, but can you bring a series of technologies that have not been used before in a fast manner that allows for increased operational effectiveness? That's the win for DoD. That's the win for the soldiers, sailors, airmen, and Marines. And they have some very specific needs that parallel those of the commercial sector. One of our partnerships with Boeing, we developed the state-of-the-art ability to clean electronic intensive environments like an aircraft cockpit quickly and effectively. That's great for allowing airlines to get back in the game and turnaround times. But think about the same thing. Think about all the electronic intensive environments, whether it's the bridge of a ship, whether it's combat information center, whether it's the cockpit of an F-35, that how many sets of hands are going through there? And you don't want to use liquid chemicals to clean that. You could just use light. It's a great solution. But you have the standard challenge of getting the acquisition system to deal with a technology it hasn't seen before.
And so what's the next step in development, Fred, right? I mean, where do you guys want to go? Where do you want to be in, say, 5 years' time?
We continue to move forward with our work both on the research side and as well as the product development side. And the idea would be to take this excimer lamp we have today and have its form factor mutate to fit the different applications that people find desirous. We certainly think the mobile application is one that is definitely worth pursuing, particularly as you have congregations of folks on buses, on planes, and that's an area that's of keen interest. But we also think bring this down into areas where people are gathering, into offices, into conferences, will bring some very, very quick resilience and some additional security to those spaces. We don't want to see our country, our infrastructure shut down again because of a pathogen. This may have been a practice run. And if it's a practice run, we need to learn from it and be vigilant to make sure that we can create hardened systems that will allow us to still be able to utilize them in the event of another pathogen like this. I would say, to me, it's really a matter of how much we can get this out into a ubiquitous environment. So this just becomes another element of light that is available when needed.
And talk to folks about the form factor, right? How big are you now? What are the models and shapes, right? And to do what it is you want to do, for example, whether it's entry on an airplane or anything else, where are you now? Where do you need to be as successful as you want to be?
So today we can do everything from a 2-inch little tile all the way up to about a 2-foot tube. We believe that will expand up to sort of a 4-foot tube, which gets to a lot of standard lighting. But we'd also like to understand how we can shape things better. We understand the material science around this is very different than light we've used before. It's absorbed by most of the materials that we would normally use as reflectors. So we have to deal with different types of beam shaping. But I think in general, if you see a form factor that light can cover, and you want coverage of the air and the surfaces, we want to be able to do that. Everything from a high bay in a hangar to a downlight in an office space.
And so what you're talking about is effectively a new light fixture that has both the disinfecting bulb as well as the light source itself.
Yes, so many of our fixtures try to accomplish both of those functions, mainly because we already have the point of power connection and connectivity already in place, and that makes the retrofit the simplest method.
What do you estimate to be the size of this market that you're pursuing? This is a vast market, isn't it?
It is a vast market, and I always liken it to the difference between the lighting market today, which is a multi-$100 billion market, but comparing it to some of the health and wellness markets, which are maybe exponentially bigger than that. So
Right.
somewhere between those two is the potential size of the market we might be willing to address here.
That's right. So even a small percentage actually means quite a lot for you guys, and that doesn't, right, in the worst case, in the best case, you become one of the big players in what is a vast market, which is in what I know what you want to do, Fred. Wes, bring us home. We've got a new team at the Pentagon. It looks like they want to drive change. Innovation is on everybody's lips. The Acquisition and Sustainment Secretary, if the Senate agrees, will be Mike Brown, who is the Defense Innovation Unit head. Heidi Shue will be the, if the Senate approves, Research and Engineering. And then former Pentagon Acquisition Chief Frank Kendall would become the Secretary of the Air Force, and Carlos Del Toro would become Navy Secretary. Everybody here has got enormous amounts of Army acquisition experience in their careers. What's the message you want to deliver to them about the need for speed and to bring innovative players into the space? I understand that you're advising and you're working with Healthe, right? So you're not a disinterested party in this, but you are somebody who's always tried to push innovation throughout your career. What's the message you want to deliver to the senior leadership team?
Well, Vago, whether it's a product or it's the process, when it is aligned with DoD interests, truly speed is life. And, if we can get things to the warfighter that protect them, it's truly a speed is life equation. Now, if I were going to look, knowing all of the great leaders we have coming in, and they're focused not only on innovation in acquisition techniques, but a focus on dual use technologies, pulling what has a commercial appeal into the DoD market at a high technology readiness level. I frankly could not come up with a better product to do a proof of concept off than Healthe and Far-UV. There is a very definite need for the technology. We have to be able to operate with a pathogen endangered environment. That's just a given. I mean, it's bad enough what has happened during COVID. Imagine if we were engaged in a kinetic battle with a peer or near peer. We couldn't just send everybody home from the Pentagon. We have to be able to work in these environments. We couldn't just pull ships into port because a pathogen broke out on it. We have to be able to fight those ships. So if we can take that stated desire to pull technology from the commercial sector that's already mature and has uses in the DoD and commercial sector, and then we can use accelerated acquisition technologies on top of it, that's really a win-win-win scenario for the government, for industry, for the taxpayer, and certainly for the soldiers, sailors, airmen, and Marines at the point of the spear.
Fred, let me ask you one wrap-up question, right? I mean, you work for NASA, which is a formidable acquisition organization in its own right, even though you were on the science side of things. What are some of the lessons learned for you as you've gone through this process?
I think the lessons learned from NASA were pretty straightforward. There was a mission that needed to be accomplished. Speed was of great urgency, but so was accuracy. And to me, this is about transparency of science. We celebrated our failures, we celebrated our successes. As long as we let the science guide us and help us towards making the right decisions, that was a culture there. We've gotten away from that a bit now. We need to get back to let's use the best science to solve our problems. And if we do that, I think we'll be in a good place in the future.
Fred, best of luck with the venture. Absolutely fascinating. Wish you all success in the world. Wes, absolutely great having you back on again, sir. Real pleasure, and look forward to following your guys' progress over the coming months and years. Thanks so very much. Fair winds following seas.
Thanks, Vago. Great talking to you.
Thank you.